this is a demonstration for how to use scripts for cleaning up ECG data. We'll go ahead and open a file that already exists. You can do this with your own data as well. The first thing we have to do is create the menus for the scripts. Okay, those were created by first creating a toolbar and then populating it with the scripts. I'll do this from scratch. I'll delete the toolbar, so now we don't have it anymore. Now we have a toolbar, and we'll go ahead and locate the scripts here. I'm just moving over all the scripts I want. And I can also change where they are. So first we usually run classify, analyze, then I'll put the count script, next, previous, and I'll explain what these do. So we have confirm, max, interpolate. Okay, so these are our scripts now. We can place them wherever we want. We can even have them right above the data, if that's how we prefer to use the scripts. But I'll just keep them here. And here's the order of steps. Let's hide the other channels. This particular data file already has some extra data like respiration. We'll go ahead and have only the ECG, which contains conveniently some artifacts. First, we have to run the classify script. The classify script will place markers indicating the instantaneous heart rate from one beat to the next. So obviously the first one is always 0. Okay. The next thing we have to do is look for some abnormalities in the data. That will be done by the analyze script. It will look for strange deviations in instantaneous heart rate. So we can define here, and the default is 15 beats per minute, what we consider to be the limit of an acceptable change in heart rate from one beat to the next. After that, we can identify the range. In this case, the default is 50 to 150 for the heart rate for this individual. So if it goes lower or higher, flag markers will be placed. Now the software has placed a bunch of flags in the data. We can see how many there are by hitting count. And furthermore, we can go now and inspect them. Now the first one is flagged because the instantaneous heart rate is 0. That makes sense because that's our first selection. So we just go ahead right here and confirm these beats. They're good beats. Star means the beat is accepted. Flag means it's a problem. So what we want to do is we want to end up with stars. This is very important. The next script just moves us to the next problematic area in the data. We can see here that heart rate suddenly becomes 34 because this QRS complex has not been detected successfully. It's due to the very low amplitude of the R peak. We can just go ahead and confirm the surrounding peaks, and we can manually place the marker by clicking on the max button because the QRS complex, specifically the R peak, is very easily identifiable, at least for the human eye. Let's go to the next problematic area, which is right here. We have the same kind of occurrence. So we just go ahead and confirm all of these and manually place the marker. Let's go to next. This one has been flagged because of the change in heart rate that's been going on here due to the incorrect beat right here. So we'll just go ahead and confirm that one as well. Let's see where we are right now. We have 7 more instances. So we'll click on next, and here we have another one. Clearly, if we zoom in, it will be quite obvious. We have an artifact right here, because this is a typical RPEAK QRS complex, and then we have an artifact. So what we're going to do is clear this marker, and then we'll manually place right here, like this, the correct marker. Let's go next. Now here we have a different kind of situation. Let's confirm these because they're all correct. What we have is a missing beat. One strategy is to have the software interpolate the location of the beat based on the heart rate before and after. Or we can choose not to use this for data analysis. Let's show how the interpolate feature works. There we go. The marker is placed where the RPEAK is expected to be for data that follows the same heart rate. So it's interpolating the location of the marker. Next location, same story. So we'll go ahead and confirm all these, and we'll interpolate. We have no more. We can zoom out and we can look at the heart rate. We can see here no dramatic outliers, which is another indication that we've done a good job cleaning up the data record. At this point, we can go and select single epoch spectral analysis. Typically, it's run using the QRS detector, but we wanted specifically to manually override choices made by the QRS detector. So we'll choose for the events to be the stars. So instead of the RPEAKs that the software detects by default, we'll go with the stars, which we were able to modify ourselves. We can make adjustments to the properties here and click OK, and we end up with the results.